Welcome to today's Explainer. I am so excited to guide you through this one because we are going to unpack a fascinating, completely invisible mystery that dictates literally everything we do. Think about it. From the absolute second you wake up to the moment you go to sleep, there is a hidden power shaping your every single move. We're talking about force. In this Explainer, we're going to use some fantastic visual examples to reveal these invisible pushes and pulls happening all around us. Get ready because you are definitely going to see the world differently after this.
Okay, let's just dive right into it. Picture this. Two friends, Sonali and Ragjini, are out for a beautiful summer bicycle ride. But it's not exactly a breeze, right? As they ride through their village, there's this heavy wind rushing right at them. Rajini even complains that the wind is physically pushing her back. So, to keep moving forward against this wind, they have to push their pedals even harder. But then, the whole situation flips. They reach a hilltop, turn back to escape an incoming thunderstorm, and suddenly they're going down the slope of the hill. Out of nowhere, their bikes are moving incredibly fast, and they aren't even pedaling. Sonali thinks it's thrilling, but she wonders aloud, something is pulling them downhill.
So I want you to think about that for a second. What exactly is pushing them? And what is pulling them downhill? What is this invisible power that can make their bicycles speed up, slow down, and even move entirely on their own without a single push of the pedals? It honestly feels a bit like magic, but as you'll see, it's just science.
And here is our scientific answer. That invisible power? It's force. Simply put, a force is a push or a pull applied on an object. But here is the really absolutely crucial part of this definition. It results from an object's interaction with another object. You don't just get a force out of nowhere. You need at least two objects interacting for a force to actually come into play. Oh, and for anyone taking notes, the standard scientific unit for measuring this force is the Newton. You'll usually see it represented by just a capital N.
This next part brilliantly illustrates exactly what we mean by interactions. Whether you're shoving a heavy cardboard box across the floor, like the example on the left, or pulling a stretchy rubber band apart on the right, you're applying a force through an interaction. Your hands and the box interact to create a clear push, while your hands and the rubber band interact to create a deliberate pull.
So now that we know what a force actually is, what can it do? Well, the effects are incredibly diverse, and they happen all around us, every single day. A force can move a stationary object. Think of kicking a football that's just sitting on the grass. It can stop a moving object entirely. It can change the speed of something, like pedaling harder on your bike to go faster. It can change the direction of motion, like smacking a tennis ball back across the net. And amazingly, it can even change the shape of an object, just like we saw with that stretched rubber band, or, when you squish a balloon.
Let's look at a really dynamic, real-world example of this. Check out this dramatic dive onto the grass to stop a moving ball. This right here is a perfect visualization of force in action. The player's hand is physically interacting with the speeding ball, applying a pushing force against it. And that single interaction actually does two things from our list. It changes the ball's direction, and ultimately, it stops a moving object completely.
Now, you might be noticing a pattern. All the examples we looked at so far, pushing a box, stretching a rubber band, stopping a soccer ball, they all involve physical contact. The objects are literally touching each other. Which brings up a really fascinating question. Do objects always have to touch for a force to happen? Does an interaction absolutely require physical contact?
To figure that out, let's look at a fantastic little mini experiment you can actually try yourself. First, take a plastic scale, or even a straw, and rub it vigorously with a piece of polythene. Second, and this is key, make sure you don't touch the rubbed part with your hand. Finally, bring that scale close to some small pieces of paper on a table, but don't touch the paper with the scale. If you do this right, you'll see something truly miraculous. The pieces of paper will actually jump up and stick to the scale. The scale pulls the paper without ever touching it. No physical contact whatsoever.
So, what is this magic trick? Well, it's not magic, it's static charges. When you rub that plastic scale, electrical charges build up on the surface. And because these charges don't just move away by themselves, we call them static charges. The plastic scale becomes a charged object, and it actively exerts a pulling force on the uncharged pieces of paper. The craziest part? This force works even when the objects aren't touching. This is exactly what we call a non-contact force.
Now, let's move on to another incredibly famous non-contact force. Imagine a ball just naturally rolling down a ramp. Or, hey, remember Sonali and Ragini coasting downhill on their bikes without pedaling? This is the exact same invisible force at work. It's gravity. The Earth is constantly exerting a pulling force on objects, drawing them straight toward the ground. The Earth doesn't have to reach up and physically grab the ball or the bicycles to pull them down, right? Gravitational force acts over a distance, constantly pulling things down toward the Earth. And this brings us to a really crucial point. Understanding this gravitational pull clears up one of the biggest, most common confusions in all of science: the difference between mass and weight. They are not the same thing. Mass is literally just the amount of matter in an object. It's measured in kilograms or grams. And here's the thing: your mass is exactly the same whether you're standing on Earth, visiting the moon, or floating in deep space. But weight is actually a measurement of force. It's the Earth's gravitational pull on an object measured in newtons. Because gravitational pull can change depending on where you are, your weight can actually change, even though your mass never ever does. Okay, so what happens to that downward gravitational pull when you drop an object in water? Does it just sink straight to the bottom every time? Well, no. And this brings us to a brilliant concept called Archimedes' principle. When you place an object in a liquid, Earth's gravity pulls it down, sure, but the liquid is actually applying a pushing force in the upward direction. We call this a buoyant force. Archimedes, a famous Greek scientist, figured out that this upward buoyant force is exactly equal to the weight of the liquid the object pushes out of the way. So if gravity is stronger, the object sinks. But if the upward force counters it, the object floats. And knowing that leads us to some truly surprising stuff in nature. Get this, there are actually rocks that can float on water. No way, right? But it's true. One of these is called pumice, and it's formed during volcanic eruptions. When a volcano erupts, lava mixed with gas and water vapor cools down so incredibly fast that tiny bubbles of gas get permanently trapped inside the rock. It basically creates a sponge made of rock, completely filled with air pockets. Because of this, pumice is way less dense than water. That means the upward buoyant force from the liquid is actually strong enough to counter its weight, and this heavy-looking rock literally floats. We have covered so much ground today, from bicycles fighting the wind to the everyday magic of static electricity to actual floating volcanic rocks. We've seen that forces, whether they're contact pushes or invisible non-contact pulls, are constantly shaping our world. So I want to leave you with one final thought to chew on. If forces are always acting on us, what forces are acting on you right at this very second? Are you sitting in a chair? What's pushing up against you? What's pulling you down? Take a look around your room right now and see if you can identify the invisible pushes and pulls happening in your own life. Thank you so much for joining me for this explainer, and keep exploring.